This is Statics Chapter 6, the method of sections to find the forces and members in a truss in two dimensions. Okay, so in your book, you have the explanation to find ED, EH, and GH. Okay, I will not do it there. You have the steps, and it's really similar to what we did before. So the moment about E to find GH, the moment about H to find ED, and so for some of the force on the Y. What I challenge you is to find the force in DC. Okay, so I will help you with that. So if we want to find the force in DC, so first remember the steps. First, do your cut. Okay, so if you want to find the force in DC, we need to get DC. So we can do that. We can do. Can we do that? Yes, we can do that. We can do that. Okay, there's different options. This one is not an option because it's one forces and three unknown, so we cannot solve. We don't have enough information. This one, so we cut this one and this one, this one, this one. Yes, we can use this cut, and we use the moment about h to solve this one, and see if we do this cut there, like this. Same thing, we have one force, two force, three force, and we can use the moment about h to find this one. Either cut is the same, and why they are the same, so why this one and this one and this one are the same. They are the same because there's no external load, so it doesn't change the external force on the side of the truss. Okay, so let's say I cut there. Bam, that's my cut. Okay, if I keep the right side, I need the force on AX and AY. If I keep the left side, I need the force at F. Okay, so let's do second. I will do the left side. Okay, but first I need to find the reaction at F. Okay, if you want to find all of them, F and A, I will do the minimum there. So find the reaction at F. Okay, so let's do the free body diagrams of the entire truss. And I just use the cut to show that I need to find a reaction anyway if I keep the left side of the right side. Sometimes, depending on how I do the cut, I don't have to do that, but there I need. So let's do the step 3, the reaction. Okay, let's do the step 3. So the free body diagram is the free body diagrams of the entire truss. Let's look like this. Okay, so I just draw the outside because that's the rigid body there is the entire truss. There is a normal force NF, and there's a Y and a AX. And there's some forces. There's a 14 kilonewton, 30 kilonewton, 50 kilonewton, and 40 kilonewton. Okay, we want an F, so I will do the moment about A. So I need dimensions from A to all those forces. So I need from A to NF, that is a 2 plus 2, that is 4. I need from A to the 40 Newton, that is this dimensions, that is 2 meter. 50 is going through the point A, so no moment from this one. I need the vertical distance between the 40 and the point A, that is the 1.5 meter. And I need the distance between the 30 and the point A, there, that is 1.5 plus 1.5, so 3 meter. Okay, I like to write my dimensions from the point where I will do the moment. Okay, so now let's do sum of the moment about A, it's equal to 0. So we have, let's go in these directions. The 40 times 1.5, that is rotating in the plus directions, plus the 30 times this distance, 3. The 50 is going through the point A, so no moment, and the 40 plus 40 times this horizontal distance, that is 2. Oops. And NF minus NF times the total distance, like this horizontal distance between NF and A, that is 4 meter. So times 4, it's equal to 0. So we have an F that is equal to 40 times 1.5, 60, plus 90, plus 80, divided by 4, and F is equal to 60 plus 90 plus 80 divided by 4, 57.5. It's kilonewton. Okay, so now that we found NF, we can do the next steps. That is for free body diagram of the left side. Okay, so free body diagram of the left side. So just the left. So that's me. Yeah. So it's like I will add. Let me show you. If I add everything there and I just keep this part. So I have this, this, this. This one is inside. This one is inside. This was inside. Oops. This. Oops. This one and this one. Okay, so it looks like this. At the point F, we have the point E, we have the point D, we have the point H, and the point G. And that's it. Okay. And the 4 that we just found, the NF, there, that is 57.5. Don't forget, we need to include all the external load. So we have the 40, and we have the 50 kilonewton. Here we go. And the unknown forces are, this one is FDC, this one is FHC, and this one is FHI. Okay, oh, this one there. Okay, the last thing that we are missing is, oh, axes. So we can write axes, X and Y. No surprise for trust for the axes, always X and Y, horizontal and vertical. And the question is to find DC. So what we will use the moment about the point where the two other unknown force meet. And at the point H, so FHC and FHI meet at A, at H. So we will use this equation, sum of the moment about H is equal to 0. So we need all the dimensions from H, okay, all the vertical dimensions. Okay, so what do we have? We need these dimensions for 40, that is 2 meters. We need these dimensions, that is 4 meters. Okay, for FDC, there is 2 options for FDC, and that's where it's really important. So let me draw that at the point C. We don't know, so if we use the vertical complement of ADC there, we don't know any dimension, so we can't do that. So we need to slide the force DC either at C, that's my FDC, or either at D. You pick one, okay, the one you want. If we use, yes, I make it big. If you use FDC, so this one, it has 2 complements on Y and on X. Okay, so that the FDC X and the FDC Y. Okay, that's a little bit big. We will do the moment about H. So when we do the moment about H, this one is going through the point H. So we need just to include this one time these dimensions. And these dimensions, so we move this force up to there or there. So this dimension there is the 2 meter. Okay, so we will use the vertical complement of FDC times the horizontal distance 2 meter, or we use the yellow force. Okay, and let's see, I split it on X and Y, And what we need, so this one on Y is going through the point H. So we need to use the force on X time this distance. And this distance is 1.5. Okay, so when you slide the force, slide it up to a point that is horizontal with the point of the moment, or that is above, vertically above the point H in this case. Okay, I know that's a lot of information. And now let's solve for FDC. So we do some, how do we do this one? Let's do this there. That's the point number 5. 5, solve equation of equilibrium. Okay. So we will do sum of the moment about H, it's equal to 0. We are at this point. So we have the 57.5 times this distance of 4 meters, and it's going in the negative direction, so minus. We have the 40 plus the 40, so this that is going in the plus directions times this distance, that is 2. Okay, horizontal distance for vertical force, or vertical distance for horizontal force. The 50 is going through H, the FHY is going through H, the FHC is going through H. Now we need to pick FDC. So either, let me put it in, so either we use this one, or either we use this one. Okay, this one with this one, or this one horizontal with this one. That will give us the exact same answer. Okay, let's do use this one. So we have, it's going in this negative direction. Yes, so minus FDC on Y, so the complement of Y times 2 is equal to 0. So this one altogether, it's 80 minus 57.5, so it's times 4. 80 minus 57.5 times 4, so it's minus 150. That is equal to 2 times FDCY. So FDCY is this vertical complement. So those triangles there, these triangles are 2, 1.5. So that's the same thing that the 3, 4, 5 triangles. 1.52 is the same thing, so it will be 1.52, 2.5, or you can use 3, 4, 5 triangles. 3, 4, 5 triangles. Okay, so we have minus 150 divided by 2, that is equal to FDC. The Y complement is the Y that is parallel to 3, so times 3 divided by 5. So FDC is equal to minus, so 75 times 5 divided by 3. It's 125, minus 125 kilonewton. Here we go. So it means that we draw the force in tension. So I should not square that. We need to include the tension or compression. So in compression. Here we go. So, okay, the key is really, I think, free body diagrams. They are so important, our free body diagrams, right? Free body diagram to find the reactions, and after the free body diagrams. And you see, we just did 2 equations, some of the forces, some of the moment about 8 for the reaction at NF, and some of the moment about H to find FDC. We just solved for 2 equations. So it limits a lot the mistake that we can do if we have less equation. But for that, we need to pick the right equation. So take your time to do your free body diagrams to analyze which side of the truss you want to keep, which equation you can use. Can you use the moment, the force? Okay, usually moments help you a lot. So that's it. See you for the last 2, one very short video and one last example. Bye bye.